June 1944. Normandy hedgerow country. American infantry pinned down by a German MG42 position. 200 yards away, three GIs assembled what looked like a plumber's leftover, a smooth steel tube with a base plate. Officers watching thought it was inadequate. 30 seconds later, the German position ceased to exist. The M2 mortar appeared primitive. No rifling, no sights beyond a basic aiming stake. Just a tube that dropped bombs through simple physics. German soldiers who first encountered it in North Africa called it the Amerikanische Rohrwaffe, the American pipe weapon. They stopped laughing after Kasserine Pass when these pipes destroyed more machine gun nests in one afternoon than artillery had managed in 3 days. This was not artillery. This was something different, something the Wehrmacht had not prepared for. German machine gun doctrine in 1943 relied on a simple principle: position the MG42 where it could sweep a killing zone. Fortify the position with logs, sandbags, and earth. Wait for enemy infantry to advance. The MG42 firing 1,200 rounds per minute would stop any assault. German gunners trusted this system because it had worked in Poland, France, and Russia. American infantry learned in North Africa that charging these positions meant casualty rates exceeding 60%. Artillery could suppress them, but the 105mm howitzer required forward observers, fire control coordination, and multiple rounds to bracket a target. Average time from spotting a machine gun nest to delivering effective fire ran between 8 and 12 minutes. German gunners simply moved during bombardment. The British had mortars. The Germans had mortars. Everyone had mortars. But American engineers approached the problem differently. They asked a question nobody else considered. What if the infantry company could deliver artillery-level destruction without waiting for battalion assets? The M2 mortar emerged from this thinking. Designed at Watervliet Arsenal, starting in 1938, it weighed 42 pounds complete. The tube measured 3 feet 1 inch long with an 81mm bore. 3 men could carry it broken down, base plate on one, tube on another, bipod on the third. Assembly time from march to ready was 45 seconds with a trained crew. The mechanism was elegant. No breech, no firing pin, just a tube with a fixed firing pin at the bottom. The M43 high explosive round weighed 6.87 pounds with a 3-pound explosive charge. Drop it down the tube, gravity does the work, round hits the firing pin, propellant ignites, bomb exits at 700 feet per second. Maximum range, 3,000 yards. Minimum range, 200 yards. Rate of fire with a trained crew, 18 rounds per minute sustained, 30 rounds per minute for short bursts. The M2 could put 18 6.87-pound bombs on target in 60 seconds. Total crew requirement, 3 men. Compare this to German equivalents. The 8-centimeter Granatwerfer 34 mortar weighed 125 pounds, required a crew of 4, fired 14 rounds per minute maximum, and needed a vehicle for transport beyond short distances. The German weapon hit harder at longer range, but mobility suffered. When American infantry needed immediate fire support in tight terrain, the M2 arrived first. British 3-inch mortars weighed 112 pounds and fired an 8-pound bomb. Excellent weapon, but required 4 men and took longer to position. Soviet 82mm mortars matched German designs, heavy and powerful but not as portable. The American advantage was speed and proximity. A rifle company could have 3 M2 mortars within 200 yards of the front line. German 80mm mortars stayed 500 to 800 yards back due to weight. When a German machine gun opened fire, American mortar crews needed 45 seconds to set up and 30 seconds to put the first round downrange. Total time from first shot to first mortar impact, 75 seconds. American mortar doctrine emphasized indirect fire from covered positions. Forward observers with radio contact, called coordinates. But the M2's lightweight allowed something German mortars could not do: direct fire. Crews could set up within visual range, aim by eye, and hammer targets they could see. This violated every conventional mortar employment doctrine. It also worked. 77th Infantry Division, Guam, July 1944. Japanese bunker complex stopping the advance. Company commander brought 3 M2 mortars to within 100 yards of enemy positions. Crews fired 47 rounds in 4 minutes with direct line of sight. Every bunker took multiple hits. The position fell in 6 minutes from first shot. German after-action reports from Normandy mention the amerikanische Steilfeuerrohr repeatedly. Steep fire pipe. German infantry respected the MG42. They feared American mortars. The difference was psychological. You heard an MG42. You could take cover. You never heard the mortar bomb until impact. 6.87 pounds of explosive, arriving at terminal velocity with no warning. 1st Army, Aachen, October 1944. Urban combat, building to building. German machine gun positions held every intersection. American infantry advanced with M2 mortars in the assault wave. Crews set up in doorways, fired 3 to 4 rounds at visible targets, displaced before counter-battery fire arrived. 17 machine gun positions neutralized in 2 hours. German defenders reported feeling hunted, unable to hold fixed positions because the pipes found them within minutes. The M43 high explosive round was designed for this work. 3-pound charge meant less blast than artillery, but better. Fragmentation. Steel casing produced 1,400 fragments with lethal radius of 30 yards. German machine gun crews typically operated from positions with overhead protection but limited side armor. Top attack angle of mortar fire meant bombs dropped through weak points. After-action analysis showed machine gun positions required an average of 2.3 mortar rounds for suppression, 4.7 rounds for destruction. Compare ammunition weight. 1 M43 round weighed 6.87 pounds. 1 GI carried 4 rounds comfortably, 6 rounds maximum load. A 9-man rifle squad assigned to support 1 mortar could carry 54 rounds, giving the crew 3 minutes of maximum sustained fire, or 9 minutes of tactical fire. Total weight, 371 pounds distributed across 9 men. German 8-centimeter rounds weighed 7.7 pounds each. British 3-inch rounds weighed 10 pounds. American infantry could carry more ammunition per man, meaning more rounds available at the critical moment. When a rifle company attacked with organic mortar support, they brought 3 tubes and 162 rounds minimum. That represented 9 minutes of sustained fire without resupply. If you are enjoying this detailed look at American engineering, consider subscribing. It helps the channel and ensures you do not miss the next analysis. Production numbers validate effectiveness. From 1941 to 1945, American industry produced 21,700 M1 and M2 mortars. Monthly production peaked at 860 units in June 1944. Every infantry regiment received 6 M2 mortars, 2 per battalion. Ranger battalions received 9. Airborne units received 12 due to weight advantages. German production of 8-centimeter mortars reached 68,000 units total, but the Wehrmacht fielded 3.8 million more soldiers than the U.S. Army. Per capita, American forces deployed more mortars closer to combat. This meant faster response when positions needed immediate fire support. Combat effectiveness studies from Normandy show revealing patterns. When German machine gun positions received mortar fire within 90 seconds of opening fire, German gunners abandoned positions 82% of the time. When response time exceeded 4 minutes, German gunners held position and continued firing 67% of the time. The M2's portability meant 90-second response was achievable. German heavy mortars could not match this. 7th Army, Vosges Mountains, November 1944. Terrain limited artillery employment. German defenders placed machine gun positions to cover all approach routes. American rifle companies advanced with M2 mortars in the assault echelon. After action reports document 43 German machine gun positions engaged, 39 positions suppressed or destroyed by mortar fire. Average time from contact to first mortar round, 68 seconds. German position abandonment rate, 74%. The numbers prove the concept. Light, fast, deadly. 3 men could carry artillery-level firepower and employ it without waiting for battalion approval. This changed infantry tactics fundamentally. American doctrine in 1945 emphasized mortar integration at company level. German doctrine still centralized mortar fire at battalion. The time difference decided engagements. Post-war analysis by German officers identified American infantry fire support as a critical advantage. Colonel General Heinz Guderian wrote in 1950 that American infantry companies fought with support that matched German battalion-level assets. He specifically cited mortars. German machine gun tactics assumed infantry attacks would lack immediate heavy fire support. American M2 mortars eliminated that assumption. British evaluation of American equipment in 1946 rated the M2 mortar among the top 5 American innovations. The report noted that while British 3-inch mortars had greater range and payload, American M2s provided faster, more flexible fire support in close combat. British forces adopted American mortar tactics for Malaya operations in 1948. The Soviets, never quick to praise American designs, produced the M43 mortar in 1943, direct copy of the American M2 with minor modifications. Soviet designation, 82 mm company mortar model, 1943. Production exceeded 12,000 units by war's end. When the Red Army needed a light, fast mortar for urban combat, they copied American engineering. Post-war service validated the design. M2 mortars remained in U.S. service through Korea and Vietnam. South Korean forces used M2s at Pusan perimeter in 1950 with the same devastating effect against fixed positions. North Vietnamese forces captured M2s and employed them throughout the war, considering them superior to Soviet equivalents for jungle combat. Modern variants of the M2 remain in service today. The M252 81 mm mortar, adopted in 1984, traces direct lineage to the 1943 design. Weight increased to 90 pounds with improved range, but the core concept remained unchanged. Infantry company asset, 3-man crew, rapid deployment, immediate fire support. Total production of M2 and derivatives exceeded 30,000 units. Export to 47 nations. Licensed production in Britain, Canada, Italy, Turkey, and Israel. When nations needed a light mortar that worked, they chose American engineering or copied it directly. The strange pipe that confused observers in 1944 proved its worth through 12 million rounds fired in combat. German machine gun positions that had stopped entire battalions fell to 3-man mortar crews in minutes. The superiority was not marginal. American mortars delivered comparable firepower to German equivalents at 1/3 the weight, with 2/3 the crew requirement, and twice the rate of deployment. American engineers solved the infantry support problem by rejecting conventional thinking. They built a weapon light enough to accompany assault troops, simple enough to fire without extensive training, and deadly enough to destroy fortified positions. The M2 mortar did not look impressive. It did not need to. The combat record spoke clearly. When German machine gunners heard the whistle of incoming mortar rounds, they abandoned positions because they knew what was coming. 6.87 pounds of American engineering, arriving faster than they could relocate. The primitive pipe proved more terrifying than artillery because it was personal, immediate, and inescapable. Artillery hit grid squares. Mortars hit specific fighting positions. Artillery took minutes to arrive. Mortars took seconds. Artillery required observers and coordination. Mortars required 3 determined soldiers with a tube. That was American innovation under pressure. Building weapons that worked when seconds determined survival. Weapons that gave infantry companies battalion-level firepower. Weapons that proved superior not through complexity, but through brilliant simplicity. The M2 mortar demonstrated what American engineering accomplished at its finest, taking a basic concept, the pipe that drops bombs, and refining it until the result changed battlefield tactics for every army that encountered it. The numbers documented it. The combat record confirmed it. The global adoption validated it. When German soldiers feared the primitive American pipe more than massed artillery, they understood what American engineers had created. Not just a weapon, a revolution in infantry fire support, delivered through 42 pounds of American steel.